Hey there, in this video we're gonna go over one of the problems that I did in the live Zoom class today. I just picked it because it was an example we had done, but one of the things that I didn't do was change my A sub n to the actual formula. So this is dealing with the principle of mathematical induction, which says that if you have a statement about n, if these two conditions are met, then the statement about n is true for all n. So from 1 to infinity. But the conditions are P of 1 is true, which means that you have to show true for n equals 1. So the statement, whatever the statement about n is, show that it's true for n equals 1. And then for every natural number k, if the statement is true for that k, then the statement is true for k plus 1. So if those two conditions are true, then we can say the statement is true for all n. So what this is kind of saying is if it's true for 1, we can continue. If you say it's true for, say, 25, then it's going to be true for 26. If you say it's true for 257, then it's going to be true for 258. If it's true for 2000, it's going to be true for 2001. And you can see how if you keep making those conclusions, then we can say it's going to be true for all n, all the way to infinity. All right. So in the problem, what I didn't do was convert my A sub n to 2n minus 1, the actual formula for the odd numbers. So I've rewritten it over here better. So we want to prove that the sum of the first n odd numbers is this formula, n times a plus a sub n over 2, which means that our P sub n, our statement, is that when you add up the odd numbers all the way to the nth odd number, 2n minus 1, what you're going to get is n times a plus a sub n over 2. Now let's simplify this formula so we can put it the whole thing in terms of n. So notice that 1 here is, this is what a is, and this is my a sub n. A sub n is 2n minus 1. So let's go back over here and write this formula using these. So my a is 1, a sub n is 2n minus 1, and I'm dividing the whole thing by 2. So notice that something interesting happens here. So the 1's cancel, and so I'm going to have n times 2n over 2, but the 2's cancel as well, right? So we're just really left with n times n, which is n squared. So this is kind of neat. So what this is saying is that the sum of the odd numbers is equal to n squared. So the first odd numbers is equal to n squared. So let's use the principle of mathematical induction to prove it. So this is our statement about n. And so the first thing is that we want to show true. So show P of 1 is true. This means show true for n equals 1. Right? So that means that we're going to take the first term, so 1, and you can also plug it in here. 2 times 1 is 1 minus 1. That gives you 1. So is 1 equal to 1 squared? Yes. So we can say it's true for that. So our second statement is an if-then statement, right? If P of k is true, then Pk plus 1 is true. So what this means is we get to assume P of k is true. And we got to show P of k plus 1 is true. So what this means is that the statement is true for n equals k. More specifically, 1 plus 3 plus 5 plus 7 plus 9 plus plus in my n statement, right, my P of n, that's my statement, I'm going to replace the n with k. So it'll be 2k minus 1 equals k squared. plus 2k minus 1 is equal to k squared. So we get to assume that this is true, right? So this is our assumption, this is true. So for this if-then statement, we want to show that the statement is true for n equals k plus 1. So that means we want to show that if I have 1 plus 3 plus 5 plus 7 plus 9 plus dot 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 plus, with proof by inductions like this, I always want to show my k statement, so 2k minus 1, and then my when n is k plus 1. So 2, so that means I'm going to replace every n with k plus 1. And so the question is that equal to k plus 1 squared? So that's what we want to show. So with proofs by induction like this, always stay working on just one side and show that it equals the other. So this isn't an equation, so don't move terms from one side to the other. So you want to keep, this side is always going to stay k plus 1 squared, and we're just going to manipulate the left side to see if these are in fact equal. Because we get to assume that it's true for k, right? Notice that we have this statement is true. Well, that statement shows up here. So I know that this is true. So this is equal to k squared based on my assumption. So that means we can rewrite this statement as k squared. So 1 plus 3 plus 5 all the way to 2k minus 1, I can replace it with just k squared. And then plus, distribute the 2 here, 2k plus 2, and then we have this minus 1. And so does that equal k plus 1 squared? We don't know, let's continue. So continue working on the left side. So I have k squared plus 2k plus 2 minus 1 just becomes plus 1. And notice that this factors. So I can factor these. So I guess let me keep writing this. And I put the question mark there to remind me not to treat it like an equation, right? I'm not moving things from one side to another. And then here, notice this factors. What two numbers multiply to 1 and add up to 2? 1 and 1. So this factors into k plus 1 times k plus 1, which is in fact k plus 1 squared. So it is true. So we have shown that p of 1 is true. We showed that. We have shown that if p of k is true, then p of k plus 1 is also true. Sorry, I have my emails on. And so because those two statements are true, then we can say, therefore, the statement is true for all n. P of n is true for all n. So what that means is, remember what was our statement? So this is that the odd numbers 1 plus 3 plus 5 plus 7 plus 9 plus all the way to the nth one, to n minus 1, is equal to essentially n squared. And that is that proof. In class, if you watched the video of the conference Zoom, the reason that it was getting so difficult was because I had left the a sub n, the a and the a sub n in there, instead of changing them to the actual formula for the odd number, which is 2n minus 1, which then just made things very complicated, dealing with that a sub k and a sub k plus 1. So it's better to change them as we did here with my a is 1 and my a sub n is 2n minus 1. Okay, I hope that clarified that one example, and I did a couple more examples in the conference room class, so if you haven't checked the recording yet, go ahead and do it, and I will see you in class next Tuesday. Email me if you have any questions.